In this video, we'll be finding the pH of weak acid and weak base solutions. These ones are a little bit tougher than the strong acid solutions, but the same principles apply, and I'll show you guys how to solve them. So in this one, they just say we have a weak acid solution. We don't know what it is, but we know it's Ka, and we know its molarity. So we have everything we need to solve for the pH. So the first step, let's write out our dissociation equation for these weak acids. And in this one we use the equilibrium arrows because it's not a strong acid. So that's our reaction, and now we need to find K. We use the same principles we learned earlier. So that's that. And in this case, our Ka is less than 10 to the negative fourth. So we can use the approximation that HA is just equal to our initial concentration because it doesn't dissociate that much. But in the next couple of videos we'll show you how to do them when Ka is greater than 10 to the negative fourth, and you have to actually find the equilibrium concentration. But for this case, let's not worry about that. As you can see here, there's a 1-to-1 ratio between H3O plus and A minus. So we can just say that those are X times X, since they're exactly the same, over HA. Okay, so now we want to solve for the concentration of H3O plus in order to find the pH of the solution. So let's do that. And then, as we know, X just equals the square root of this stuff. So now we're ready to plug in some numbers. Take the square root of all that. And when we do so, we figure out that it equals and this is just equal to our concentration of H3O plus, as we showed earlier, which is just equal to X. So now that we have H3O plus, we can solve for the pH. pH is just the negative log of H3O plus. So and when we do that, we get 1.9435. We have 4 significant figures here. After taking the log, you should have 4 significant figures past the decimal. So that checks out. So our pH is 1.9435. So that's the solution for a strong acid, or a weak acid. Now let's work on a weak base solution problem. These ones are the same principles, but in this case they're giving us a Ka for the weak base. And so what we actually need in order to find the weak base pH, we need to find Kb. But using our relation we learned, Ka times Kb equals 10 to the negative 14th, which is just called Kw. So we can solve for Kb. We plug in our Ka. And after that, we should get (10⁻⁶). Okay, so now we have what we need with the Kb. So now let's write out the equation for the dissociation of this base. So since we don't know what base is, we're just going to call it A minus. Use the equilibrium arrows. Okay, so that's our equation. So now we need to find what Kb actually equals. In this case, it's just HA times OH minus over the concentration of our base. And in this case, our Kb is really small. It's Kb is less than 10⁻⁴. So in this case, we can use the approximation that our initial base concentration is just equal to the initial concentration, which in our case was 3.453 molar. Okay, so now what we want to find is we need to find OH minus. That's what we need to find the concentration of. So we can do that algebraically, and by looking at this equation here, we see that HA and OH minus are exactly the same. So let's just write them as X times X over A minus. And just like we solved it last time, and then we can plug in our values now. And the concentration of our base from the start was 3.453 molar. And after taking the square root of that, we should get our OH concentration as 7.453 times 10⁻⁵. And that's our OH minus concentration. Okay, so now that we have that, we have everything we need to find the pH. So let's start by finding the pOH. It's just the negative log of the concentration of OH minus. And in our case, we find the pOH is equal to 2.1276. 4 significant figures. 4 significant figures past the decimal, so that checks out. That's right. And then the pH is just equal to 14 minus the pOH, which in our case comes out to equal 11.8724. So we showed you how to find the pH of weak acids and weak bases, and we did them for values of Ka or Kb less than 10⁻⁴. So there is different cases that you have to do if the values are greater than 10⁻⁴, which you'll see in the upcoming videos. Thanks for watching.